This tutorial is to show you how to put together a program that uses files. So what we need to be able to do here is we need to be able to read files, we need to be able to write files, we need to be able to add to files that have already been created, new content without destroying what we wrote before. And those are actually three separate activities. Where we add onto a file that has been written to before, this is called appending. It is non-destructive. If we do a file write, this overwrites whatever the file was before. That is destructive. It obliterates anything you have before. So you have to be very careful with files. In addition, files call upon the operating system of your computer to write and read from file. So for a moment, your program turns over control of the computer to the operating system. And if something goes wrong in that process, you can actually crash your computer. This is a very dangerous thing where you turn over control of your computer to the operating system. So for the program that I'm putting together right now, I'm calling this Files 1. I'm putting this into my Visual Basic folder in Chapter 8, and I will say OK. Now, to do what I'm about to do, you should have your notes open to Files in Moodle, because I'm going to copy and paste code out of what I have there in programs that have already been created to create what I'm about to do. So if you would, go ahead and open up your Moodle's notes to Chapter 8. Now, before I go too much further, there are different kinds of files we're going to work with in here. The two main types of files we'll work in here, and there's actually more depending on how you describe them, are sequential files and database files. We will use with both types in Visual Basic. First type we're going to work with is sequential file. And it's called a sequential file because before you get to the next line that's written, you have to write the line before. Everything has to be done in order. So it's just like how you write things on a piece of paper. In essence, that's kind of an analogy of how this is done. Before I can get to a spot in that file, say the 100th line that's been written, I have to read all 99 lines beforehand. That is not how a database works. A database works by allocating so much space to each file. Maybe we would say just for an example, maybe 100 kilobytes for one thing, and then 100 kilobytes to the next thing, and another 100 kilobytes to something else. So that if it's looking for a particular file, all you have to do is just say, okay, what group of data is it in? And it can skip down to wherever it should start and start reading there rather than reading from beginning to end. This is the way that CD-ROMs work. If you have music CDs, you have a first song, a second song, typically maybe at most 20 songs or something like that on a CD. You're actually asking to switch between songs. Files work the same way. In fact, they were created this way on files long before they were ever created for music CDs. So anyway, the way we're going to focus in this particular chapter is going to be on sequential files. We've already started to do this with the dictionary file, which we read. Now, what I'd like you to do right now is let's skip down just a little bit. We'll take a look at this Intro to Files program. First thing I'd like to do is let's create a destructive file write to files. So I'm just going to look at this, and I'm going to make an interface that sort of mimics what I see here. Let's go ahead and on this form that I have here, let's go grab a button. I'll put it on here, and I'll write the same thing that you saw on the form. I'll say that this is going to be a destructive file write. Now, most file writes are destructive. The only one that isn't destructive is, as I said before, an append. Appending is not destructive. Let's go get a list box, and I'll put it over here to the right, and I'll go back to my notes now, and if I skip down just a little bit, I'll see what I have here for button 1. I'm just going to copy the code, including the comments that I have here, and I'll come back to my program and I'll paste it into here. And if you haven't got your notes ready, you're just looking at what I'm doing here, you can just look at how my program runs as though it were your program on your computer. Now, You'll notice the first line is pretty interesting. Dim X as, we've seen this before, IO dot. This means we're getting ready to do input or output. That's what IO stands for. StreamWriter is the object that I get at. If you were to lay down a period after IO, you would see a lot of choices that you can choose here. The one you want to use is StreamWriter. Equals IO.file. We're going to create text. I must warn you that if there was a file in the innermost debug directory before that was called writer.txt, after this line is executed right here, it is obliterated just with this one line. It is destroyed. Nothing else exists there after that point. That file has been wiped out. This is destructive. This one line right here. The next line I've got shows how to write a single line of code. Just as we read a line by saying read line, you just declare the object. You just write down the object, which we're saying is X here. You say dot, and by the way, there's nothing special about the name X. You could write anything you wanted to here. It's just a variable name. I lay down a period. One of the choices I can choose here is write line. Then within parentheses, if you use quotes, anything you say there will be written to file, and that will constitute one line. The next line, right line that you have, will be written one line below. It's almost like writing stuff out to screen or as into list boxes as we've done before. This is going to be very similar to writing out to a list box, except we're not writing out to the list box. We're actually writing out to a file in your hard drive on your computer. The most important line probably I have here, aside from writing the lines out, is this last one here. I cannot tell you how important this is. The computer is very, very lazy in a way. It only does things when it's forced to do it. So the only thing that actually causes all of these lines of code to be written out to file is this last one, which says do the job. That job has to be concluded at the end of this line. So this is what actually forces the file write to happen. If you neglect to put this line on here, nothing will ever be written to file. What I'd like to do right now is let's go ahead and rebuild our code here. And I'm going to run the file. So I'll say start debugging. And I'll click the button. On the click of the button, a file was created that never existed before called writer.txt. I wrote out these 4 lines on separate lines of code to that file. It was placed within your innermost debug directory. I know it happened because if it didn't, my computer program would have just crashed. It would have crashed pretty hard. All of that actually happened when I said x.close. This is kind of a funny thing. Computers are a lot like people. They don't do anything till the last minute. And this is what forces them to actually do it. All of these commands are held virtually in memory. It actually allows your computer to operate a little bit quicker by doing things like that. It just does things when it has to by lumping all the tasks together and doing them all at once at the last minute. It's going to save time, and it's going to allow it to do more of other things for you, otherwise that it wouldn't do. Let's go look for that file that we just created. If I go to File, and I want to make sure I'm not running my program that I've got here, I am, so let me just close it. If you go to File, and you open a file, and you go to your innermost debug directory under File 01, bin, debug, right there is the file that I just created. And again, that file was created at the conclusion of this very first line, even though maybe technically you could argue it wasn't actually created until you hit x.close. You'd probably be right in saying that. You can go ahead and open this file. And what you should see is everything that we just wrote to file in our program. It should all be there. So the meaning of life is a milkshake and watching TV on a Friday afternoon after school and programming. Of course, after programming. So anyway, guys, you can see the effect of this. So it's very similar in a way to reading a file and seeing what's on there, except now we're using write line and we're using create text instead of open a file as we were before, but we're still closing it at the end just as you guys had to do when you read it. Okay, I'd like to add a new button to your form that mimics the next thing that we see on your program that I have in your notes, which is a destructive write to file again. So it's going to look exactly like our last one. To do this, let's just copy the last button and I'll lay it down. I'm saying this is destructive also. Let's see why. I'll go back to my notes. We'll skip down just a little bit and we'll grab the code on form or on button 2. And let me post it onto this button, the code. Now you'll notice I've got the same line of code before. Dim X is IOStream reader, so X is going to be the object that I'm going to use to write out to file. Stream writer, if you look at the code I used before, I was using the same command. IO file create text. Create text is going to obliterate anything that's there. I'm going to call this writer.text. I can tell you when I run this line, it's going to destroy everything in the file that I had before. It's all going to be gone, and I'm going to create something new. What am I doing here? I'm going to create 1 million numbers and write them all out to file one at a time. You're about to see a list counting up from 1 to 1 million. That's actually what we're going to see. How long do you suppose it'll take to write that file, guys? 1 million numbers written to file. A couple seconds? Well, let's see. If I go ahead and rebuild this. Now, the interesting thing about this is before we were writing out text to file, now we're writing out numbers. Visual Basic doesn't care what you write out to file. It'll do anything. Let's go ahead and, you know what, I technically won't know how long it takes to do it unless I give myself a message here. What do you say we put in a message box, quote, done, and when I see this message, we'll know that we're finished writing out to file. I'll go ahead and rebuild this and run it. Let's click on that button. Well, it took a little bit of a pause there. I could see it thinking. Let's go look at the numbers 1 to 1 million. So it says here the file has just been updated. You bet it has. I just wiped out the last file. Let's say yes to all. I do want to reload it. Let's look at that file. Guys, this is a list of numbers written 1 to 1 million. You can look at any number you want to from 1 to 1 million, and I can tell you it's there. We just did it. Now, if you think about it, that's pretty incredible, isn't it? That's amazing. You would. I've just been asked, can you make this program as big as you want? You can. The real issue would be integers are going to run out of gas pretty early. They're only good up to about 1 billion. So you could make a list up to 1 billion or 2, and that'd be okay. If you want to go for really big numbers, like if we're talking about with 300 places behind them or something like that, don't declare it as an integer. You're going to want to declare I as being, you know what, I don't even see the declaration for I here. I probably should say dim I as, make it a double, and then you're really going to be able to get into some serious numbers there. Certainly with at least about 15 places, you would be able to see those if you wanted to see it. Now, I'm not interested in doing it. I don't want to sit here all day long looking at this create crazy numbers, you know, but I could do it if I wanted to. And again, you saw that everything we typed before is gone. So it was destructive. Let's go ahead now and go to our notes again, see what the next thing is that I have here. So I have a non-destructive write to file. This means I'm going to save the information I had from before. So let's go ahead and create that program. So I'll just copy this last button, lay it down, and I'm just going to change it to non-destructive. And if it's non-destructive, I know this is going to be an append. Appending exists in every computer language I'm aware of. You should be able to read and write to file destructively, or you can append. And appending just simply means you tack on to wherever the file left off. It's easy to picture in your mind. Let's go now to our code in the notes. And I'll scroll down just a little bit, and I'll copy all the code I've got here, even the comments, and I'll paste it onto this button. Now, what's the difference between this and the last thing that we did? Well, if you look at the dimx command that I have, that's all the same, and I'm still dealing with a stream writer object. I'm still going to write stuff out to file. I still have IO, that's the same, file. You'll notice the difference is in the next word, Here I'm creating text. Down here I'm appending it. So if you can just remember that, that's all you have to do this. After that, all the code is the same. You're still going to use the write line code to write stuff out to files, so it's going to look identical. The only difference between this program and the one I did in the first place is maybe what I'm writing out to file and the fact that I'm using append text here instead of create text. That's it. Let's go ahead and rebuild our file. I just wrote 1,000,000 numbers to file. It tells me I've got some build errors. Let's see what the issue is. Oh, I have a couple insubs here. Let me delete one of them. You might have done the same thing. If I rebuild this and run it now, I'm going to do a non-destructive write. Just basically, I'm going to say assume makes an ass out of you and me. So if I click on this, and now I close my program, it says my file's been updated. If you go to writer.txt, I can still see all those numbers I wrote to file before, but if you go all the way to the bottom, we should see, this might take me a while getting there, the message we just wrote. I just saw it. There it is. And you can see what append does is it tacks on to the end. It is non-destructive. It's a smart thing to do. It's really, really dangerous to delete an old file, say we're going to create a new one, especially if you're depending on that information. Because if anything goes wrong during that file write, if your computer crashes or something, you can lose all the information you've had before. And I think all of you have had the experience. You had something that was really important to you before that you lost because a computer crashed. It's just something we have to concern ourselves with. So wherever you can, you want to be smart about how you save things. You don't want to lose the original information. Now I'm going to go back to my notes. And the next thing that I've got on here for a button is something that says it reads from file. So let's go ahead and copy the last button we had on our form. And I'll paste it down again, and I'll say we will read from file. And I'll go back to my notes. And we're looking now at the fourth button that I've got here. And I'm going to copy the code. You have seen this before. This is very similar to the code we wrote for the dictionary. So I can paste the code here, and all this does is it will read the 1, 2, 3, 4, 5, 6 lines which are first in whatever file you have. Now I just wrote the numbers 1 to 1,000,000, so I know all 6 of those lines exist. I'm actually able to write them, but I've got to warn you. If those lines didn't exist, if I only had 2 lines in my file and I tried to read 6, you would be looking at a big crash here. You got to make sure that this stuff exists. So if I rebuild it and then I run it, I should see maybe the first 6 lines read from file. Notice now I'm looking at an IO stream reader instead of a stream writer. It's IO file.open text. I need you this chapter to get familiar with these commands. I'll click the button. There you go. There's the first 6 numbers counting up to 1,000,000. Now, how would I get it to add all 1,000,000 lines? Well, I could just copy this last button, lay it here. I'm actually going to do it. This is going to take a while to show. You want to read 1,000,000 lines from file? It'll probably take you hours to do it. It's crazy to just write every time you want to read a line, read it into temp. I think what I want to do is I want to read a line and just have 2 lines that read a line and add it to the list box, and I'm going to employ a loop since this is something that we're doing over and over. So I'm going to say do while. Now, what's the object I'm dealing with and I'm writing with? It's the X object, right? I lay down a period. Does anyone know what I'm going to look at next? I'm going to peek ahead to see if that line is there. And I'm going to say, while this is not equal to, does anybody remember what the command was? -1. And then after this, I'm going to say loop. And that actually should loop through all 1 million numbers that you have in your list box. Guys, if you tried to run that program, you'd be here for a long, long time waiting for that to happen. What I can do is, I could go back to my program, shorten it up a little bit. This was a destructive file write where I wrote the numbers 1 to 1 million. We just make it 1,000. That's pretty reasonable. I'm going to go ahead and rebuild this. And first I'm going to write destructively 1,000 numbers to file, obliterating the 1 million that I had before. It's done. Now when I read from file, I'm going to read 1,000 numbers from file, display them in my list box using that loop you just saw. And if you check it out, there they are. At this point, this concludes the tutorial on reading and writing from file.